Well, good morning, good afternoon, and good evening, everyone, and welcome to today's webcast, Eliminating Costly Workovers to Advance in Oilfield Efficiency. I'm Craig Fleming, Technical Editor of World Oil, and will be your moderator today. Electric submersible pumps have been in use for a long time, but conventionally they're installed in line with production tubing. By eliminating the need for a rig after the initial install of the permanent completion, operators save significant cost, reduce carbon footprint and mobilization time, while minimizing deferred oil production. Joining us for today's webcast are Jeremy Albright, Lead Sales Specialist, and Rogelio Cantu, Senior Engineering Manager, both from Baker Hughes.
Hey, good morning, Craig.
Jeremy oversees. Hey, welcome, Jeremy. Jeremy oversees the alternative deployment business in Alaska for Baker Hughes. He started working with Access ESB in 2021, followed by the acquisition by Baker Hughes in the fourth quarter of 2022. Before this, Mr. Albright worked for 20 years in the U.S. and internationally in operations, sales, and business development for Welltec and Schlumberger. Jeremy holds a degree in Business Administration Management from the University of Alaska Southeast. Rogelio is Senior Engineering Manager leading new product development activities for the Baker Hughes alternative deployment business. His 14 years of experience in the energy industry encompasses the areas of production systems, intelligent completions, subsurface communications, and formation evaluation, yielding a growing patent portfolio. Working jointly with some of the largest operators and government agencies, Rogelio is enthusiastic about working with his team, bringing to life technologies that improve efficiency, reduce costs, and advance sustainability efforts in our industry. Before we get started, let's review a few housekeeping items. You can ask questions at any time during the discussion. Just type your question in the Q&A box located on the bottom left corner of your screen, then click the Submit button. We'll ask the submitted questions at an appropriate time during the proceedings. If you're experiencing problems with the program, press F5 on your keyboard to refresh the presentation. You can also visit the Help Guide by clicking on the Help button below the slide window. Now let's get started with today's panel discussion. So what are the problems operators are facing when retrieving a conventional ESP system from challenging wells or remote locations? Jeremy, you want to take that one?
I will, yeah. Thank you for the introduction, Craig, and welcome everyone. Appreciate your attendance today. To really discuss, what operators are facing when retrieving conventional ESPs, it really comes down to three primary things. First, you have high workover cost. Many operations today do take place in remote locations, offshore installations, and other sensitive environmental areas. All of these factors do contribute to a high cost of performing a full rig workover intervention. Coupled with that, you also have a high time between the workovers themselves. There's often limited availability of the rigs that might be needed to perform this work on the failed wells, and this can also cause shutdowns of months or even years to the production of that given well. And then finally, that leads directly into, of course, then the lost and deferred production. The extended time between ESP failure and potential rig workover can have a significant impact on the production of the well itself.
Good deal. Thanks for that input, Jeremy. Now, can you discuss some of the standard approaches to running and retrieving an ESP and the challenging those bring?
Yeah, ESPs have been in use for many years, and traditionally they have been installed, as you mentioned earlier, in line with the production tubing as part of the completion itself. The standard approach has been, to design and run an ESP is to plan for what you expect your production might be, and install that ESP system based on that information, and then you'd run it to failure. All while hoping that the assumptions that you did make during that planning stage were correct. The challenges that can then bring is with a conventional ESP, a failure of any component on the ESP system, so either the motor, pump, seals, cable, or MLE, all results in the same thing, and that's requiring a rig to come on location to pull the entire completion and replace that given failed component. Further to that, changes in the production index over time and changes in ESP sizing and errors that might have been done due to incorrect assumptions or insufficient data at the time of installation also require you to then pull the completion with the rig on the well. In areas that then suffer from rig scarcity or where heavy workover costs are high, this can be particularly painful for the operator. Also, not knowing when that might be needed can be problematic. In this particular setting, ESPs have typically been run to failure, and then the problem with that is also never knowing when the failure is going to occur and making scheduling an issue.
Good deal. Thanks for that answer, Jeremy. Now that we discussed the standard approach, what is Baker Hughes doing to overcome these challenges? Is there an alternative or disruptive method? Rogelio, you want to help take that one for us?
Sure, I will, Craig. And thanks again for the introduction, and thank you everyone for joining in. And so basically, the solution that we're bringing, from Baker Hughes, is the Access ESB retrievable rigless ESP system. So this technology goes by other couple names, Twin Retrievable ESP, Wireline Retrievable ESP. But at the end of the day, we're replacing a rig with a light intervention service in order to pull pumps out and to put pumps back in. So with this system, that allows you to use a light intervention, such as slick line, E-line, or coiled tubing, depending on the availability that the operator has on location. And then you can redeploy a new bottom hole assembly consisting of pumps, motors, seals, using the same light intervention equipment. So at the end, what you gain is you're able to put your wells back in production much faster and at a fraction of the cost. And one important distinction between the conventional ESP system and the rigless ESP system is that, as you can see on the current slide, any failure on the motors, any failure on the seals, any failure on the pumps, and as Jeremy mentioned, any changes on production index or sizing errors will require you to get a rig and to pull the entire ESP completion out of the well. With the rigless ESP system, only a failure on the cable or the power delivery system will necessitate you using a workover. Everything else, whether you want to change the pumps or the motor, can be done using a slick line.
Excellent. Thanks for that answer, Rogelio. Now, how do operators know if their well is the right candidate for Access ESP retrievable system? Jeremy, you want to take that one?
Yeah, sure. I'll take that one from you, Craig. For a typical application, obviously the well that you're going to be installing the system in would be expected to require artificial lift at some point. Otherwise, there's no need for an ESP. Also, as I mentioned earlier, in areas where you have high workover costs or rig scarcity in particular. Also, if you're just sensitive to a loss of production, your intervention costs may not be particularly high, but if the availability of a rig is low and you don't want to have that downtime for the well, you'd certainly be a good candidate for the Access ESP retrievable system technology. And in terms of sizes of production tubing, typically we would need to have 4.5-inch or larger production tubing and 7-inch or larger casing. Additionally, if frac through capabilities are needed, the Access ESP system is capable of having a frac pumped through it, allowing you to install your entire final completion string prior to the frac itself. There's also other non-production specific applications, such as post-drilling cleanup. And in fact, rigless ESPs have already replaced a number of traditional coiled tubing nitrogen lift jobs for offloading of drilling fluids and helping to kickstart natural production on wells in the Middle East. This particular service is called Jumpstart.
Excellent. Thanks for that, Jeremy. Now, can you share some more information about the details on how Access ESP system actually works? Rogelio, you want to help us out there?
Sure, I can take on that one. So basically, the system is divided into two main components. We have a permanent completion component, and we have a retrievable component to the system. So the permanent completion side is designed to last the life of the well, and it essentially functions as also as a subsurface or a downhole docking station for your ESP system. So that one includes the whole power delivery system, which means the cable. It contains the wet mate connector at the bottom, and a field testable tri-lead field connector, which acts as a standard MLE. So that's a part of the permanent component. Now on the retrievable side of the component, that part we divide in two main, let's call them subassemblies. The first subassembly is the motor subassembly. This one contains a wet mate connector, as you can see on the screen, and then it also contains a motor, the seal, and a gauge assembly. Then we have a second subassembly which contains the pump, an intake, and a discharge. Then we have a third assembly which essentially serves as an anti-recirculation element. It's a tubing pack-off, and the final element is a tubing stop which anchors the whole system into position. And the way it works is first the permanent completion is run with the standard production tubing. So that's run with a rig. Once that system is deployed, the first run on the retrievable side, which contains the motor assembly, it's lower into position. We have and I'm going to go sort of top level on this one, because the way it functions is can sound a bit complicated, but in general terms, the first element that has a wet mate contains an orienting mechanism to make sure that we are all aligned before we make an electrical connection. And the wet mate itself is located as a side pocket to the mandrel. So this allows us to have a full bore access, and it works similar to a kickover tool. So if you're familiar with gas lift equipment, this system is very analogous to that, on which the connector comes out of the main bore and connects to the side of the permanent unit. So we run into position. We deployed using, typically this is run with slickline. That's the primary method in which we operate. But as Jeremy and I mentioned earlier, you can run it with E-line, you can run it with cold tubing, but it's the same operating principle. Once the system is deployed, we run it with a standard GS running tool. We come out of the hole, and then on top of that, we connect what is called the pump run, which is the second run. So very similarly to that, we just go downhole with the pump. Once we reach location, we have a set of self-aligning, teeth for the couplings for the shaft. Everything self-aligns, and we just shear off with a GS tool, come out of the hole, and then we go and pick up our third run, which is our tubing stop run. And that one, as I said earlier, it acts as an anti-recirculation element. So this prevents us from sucking the production fluid back into the intake. We set the tubing pack-off against the production tubing, therefore creating a seal. And then on top of that, we run a tubing stop, which is essentially an anchoring device. And each one of these runs, you just jaw down, release the GS tool, the running tool, and come out of the hole. So very simple installation. And you could think, well, I mean, why so many runs? Why can you just run it once and be done with it? And the answer is no, and for several reasons. The main one being, we try to keep each one of those runs fairly short, compact, and light, which allows us to run in live wells. We can just simply run on a lubricator, and you don't have the necessity to kill the well, so that you can do an ESP swap, which it has tremendous advantages. So, I mean, in general terms, that's how the system is running. And to replace it, you just do the exact same sequence in reverse. You start pulling off the tubing stop, pull off the pack off, pull out the pumps, and then finally the motors. And one quick thing to add here is in some cases where, for instance, large amounts of debris are encountered on the wellbore, and let's say you experience a lot of erosion on your pumps, you can just simply retrieve the pumps and leave the motor connected, and just save yourself even more money and more time on your operation.
Good deal. Thanks for that, Rogelio. We know that there are other ESP systems on the market. So what makes Baker Hughes Access ESP system unique? Jeremy?
I think I might let Rogelio touch on a few technical things here at first, if that's all right.
Perfect.
Sure, absolutely. So yeah, as far as the on a system on a technical level, for the system, there's a few competitive advantages that we bring to the table. So the first one, we have the best retrievability for these type of systems. The fact that it's run in 4 different completions, and the fact that we have a large amount of debris tolerance make this system very easy to retrieve, even on conditions where you have a large amount of debris and if you have pipe scale. The last 2 components that we pull out of the hole are very, very short, very, very light, and that itself, gives us a very good chance of pulling the quote unquote heavier elements, which is the pumps and the motor, much more easily. So another one I touched upon earlier, which is the full bore access. So once you pull the retrievable assembly, once you pull the pumps and the motors, your access to the bottom of your reservoir is unrestricted. You have the same idea as you will have essentially on your production tubing. So you can actually run logging runs afterwards, and you can do remediation work below your system. It gives you that access, and also that makes the system very debris tolerant, as the wet mate itself, it's standing to the side of the annular space. Another unique advantage we have is we have very strong patents on our wet mate connector system itself. So without divulging too much detail, we run extensive testing on it with high pressures, high temperatures, dozens of connections one after another, and it performs really, really, really well. So that's another advantage. The co-development we did, with other operators, which resulted in up cable. That's another unique advantage. So up cable is an alternative to standard ESP cable for some applications that are either very harsh or in very critical wells. And you can think about it as just replacing the lead on your standard ESP cable, with an Inconel or stainless steel tubing. So it looks and behaves very similar to a tech line. So number one, you can run your completion with metal-to-metal seals all the way from the surface to the wet mate connector. So no moving parts, 100% metal-to-metal seal in your completion makes it for a very, very reliable system, and which is enabled by up cable. And another one is the motor that we have. So we have a very unique design on our permanent magnet motor. It has a very high power density, which allows very small and light runs. And at the same time, we have compatibility with all of any surface equipment. So whether your drive goes, if you already have a pre-existing drive, we make the motor work with a drive that the operator has. So that's a very good advantage. And the fact that we have, going back to the retrievability and the small runs, because we have that, we can operate in live wells and do live interventions. And there's more unique aspects to the system, more on the commercial side that I'm sure Jeremy can explain.
Excellent. Yeah, thank you, Rogelio. One of the interesting things about this Access ESP system that is it doesn't really compete directly with other ESP service providers. What you're really doing is you're competing with rigs and deferred oil production. And what the system does is that, it allows you to lower your OpEx, really, helping you to maximize profits and streamline operations with a real game-changing solution. By eliminating the need for a rig after the initial install of the permanent completion, customers can save significant cost, reduce mobilization times, and minimize this deferred oil production and reduce carbon footprint, as we've already mentioned. Operators are able to get production online sooner and demand their operations. This then, of course, frees up valuable resources that can be put to use elsewhere. And of course, the cost reduction just by performing well interventions can be significant over that of needing a workover rig itself. All of this really helps to improve ROI on a given project. You can efficiently extend the run life of the wells, all while boosting production and getting the most out of a given well slot. All of these really tie in together, and work with the system and streamlining operations and giving you as an efficient of a system as you possibly can. One of the things that we haven't really mentioned too much of in terms of cost savings up until this point, I guess, is also the fact that this system then doesn't require any kill fluid to perform your workovers. All of these can be performed on live wells. You don't have to, put that kill fluid on your reservoir, potentially causing you additional issues on getting that well back up and running once the intervention is complete. And finally, what this can also do is help you reduce carbon emissions while improving the overall HSE impact of the project itself. We're able to achieve maximum efficiency while reducing personnel exposure. You have overall fewer people involved with the operations themselves. There's less equipment involved, therefore less emissions. You're providing improved well control by intervening without a rig and having to pull wellhead and install BOPs and whatnot. And just, simply displacing a heavy workover provides significant reductions in both emissions and potential man-hour savings, thereby reducing your potential HSE impacts.
Great, thanks for that, Jeremy. So are operators big advocates of this technology, or are there specific case studies that showcase system benefits?
Yeah, absolutely. So right from the beginning, right from the origins of this technology, it was essentially co-developed with operators. So one of the main pain points was a large operator in Alaska. As I mentioned earlier, a very high amounts of sand, solids, and pumps wearing out within months. Now in Alaska, it's particularly bad because you have huge rig scarcity. So that combined with the fact that pumps were failing so often, it was, let's say the operator was in a tough spot. So the original system got funding from that operator in around 2008, 2009, and it started as a development of a lightweight and high power density motor, which eventually evolved into the full Access ESB retrievable ESB system. And when that idea was generated, there were 4 key requirements to that technology. Number 1, it had to have the full bore access. Number 2, it had to be compatible with existing surface electronics. Nobody wanted to just change all their drives and surface to be compatible with this. Number 3, it had to be able to run with standard slick line. We typically use up to 0.108 slick line, so super cheap, super widely available. And number 4, as Jeremy mentioned earlier, it was critical that it was a live well deployable for all the advantages that Jeremy mentioned earlier. So that happened early on the life of the company. We started doing some pilot wells, and speaking to the same thing, in 2017 we had another co-development with two major global operators to come up with up cable. So they saw some of the advantages of the systems, some of the key features that they like, and to go along and let's say bring it to the next level, they invested as well on up cable development, which that takes away any failures or minimizes dramatically any failures associated with cable, and then we can run completions that are essentially 100% metal seals all throughout. And that development was very, very fruitful. We have some installations around the globe with that new product line. And I mean, just in terms of like mechanical, let's call it resilience, it's about 6 times more resilient to crushing and impact than standard ESP cable. So, you can get a little rough with it without really damaging it. And 2019, we had a co-development with an operator on the Middle East. Jeremy touched upon this earlier as well for the Jumpstart system. So over there, we're replacing nitrogen jobs using coiled tubing, which is coiled tubing units are very scarce in that region, and nitrogen same scarce and very, very expensive. And we are offloading wells with the Access ESB system, and that was very driven, also by the operator. And lastly, 2020, we also had a co-development with a major operator to develop a deep water, high power ESP system, that takes us to the next level of this technology for deep wells, deep water. So every step of the way, every milestone that we've had, operators have been, excellent partners on the development. I mean, they believe in the technology, and we're, forever grateful to them because, they're taking a risk, going to somewhere new. It's always risky. So, so we really appreciate the, the fact that they are willing to go with us hand in hand for some of these developments. And I mean, Jeremy, I'm sure you have a couple of, you have some assessment based on, case studies that can speak to this relationship.
Definitely, yeah. I do have one case study I'd like to speak to in particular, but I did want to mention one thing in regards to Jumpstart that you mentioned there again, Rogelio, is that these wells that Jumpstart is being used in aren't going to necessarily be long-term ESP production wells. The Jumpstart system is simply being installed to help offload and kick off the naturally flowing well. So essentially, the system's installed with the rig. We then run in the Retrievable. The well is allowed to be kicked off and get that heavy completion and drilling fluid out of the well bore, at which point the well can start flowing naturally again. We would then pull the Retrievable portion of the completion and install an isolation sleeve if necessary, and the well will just go on about its business producing naturally. There is then, of course, the option of deploying an ESP at a later date if it's required by the production of the well, and it does need that assistance at some point, but it's something that isn't necessarily required. The point of the Jumpstart system is essentially just to get the well kicked off, and not necessarily to provide the production of the well over the life of its deployment. All right, so on to the one case study I would like to mention. This is an Alaska case study from up here in the operations that I'm involved in. However, this did take place prior to my joining the company, but I definitely am impressed by what I've seen, both with this case study and other deployments that we've had here in Alaska. It really highlights some of the advantages and the savings that can be had with the Access ESP system. So an operator here on the North Slope chose to deploy one of the Access ESP systems. After the initial installation of the permanent completion on the rig, the Retrievable was then installed by a combination of slickline and coiled tubing due to the deviation of the well in question, and that was performed back in February of 2014. After 20 months of operation, the production data was indicating that pump performance had degraded, and then a preventative swap was planned for the entire Retrievable assembly. Essentially, the operator wanted to see what the pumps and motor and everything downhole looked like after that initial 20-month run. That equipment was removed from the well, and a replacement was installed, and then a defer was performed on the retrievable assembly. It did show considerable wear of the pumps, as was expected, due to the change in production that had been seen, and pumps had been worn by abrasive solids being pumped through them. However, the motor itself was still in good shape and still operating within spec. Due to these findings, the operator then chose to perform pump swaps on 3 occasions over the next 3 years when they saw a similar degradation of performance at the well. They were comfortable with the motor and the other portions of the system and knew that at that point they only had to do a pump swap. Finally, after 4 years of production, the operator had seen some additional degradation of production, and then again chose to perform a preventative retrievable assembly swap, so they could again have a look at the motor and see how things were doing, just even though it's still been performing within spec and no issues had been seen in particular. Finally, after that next BHA had been installed, they developed a leak in the production tubing itself, and this then caused the well to be shut in and became a workover candidate. So what are the takeaways from this particular case study? Really, it's over 6 years of operations. There were 2 full retrievable swaps and 3 pump-only swaps, all of which were planned and were not a result of failures. So what this really means is that, rather than having potentially up to a year of downtime that you might have had over that 6-year span due to wells failing and then needing to wait for a rig to be worked over, et cetera, but really a total of about 7 days of downtime is all that was seen on these particular wells, because they were able to plan out their interventions, have things ready to go, shut the well down, change out the assemblies, and put the well back on production immediately. It's really something that you can't do any other way with any other system at this point. One thing that Rogelio also mentioned earlier is the ability of having full bore access below the Access ESB system. And that's something that we've utilized on other wells, not this one in particular, but you're able to then pull that retrievable assembly out of the well. And in some of these heavy solids production wells, you do have a buildup in the tubing and in the lower completion. You're then able to go in with coil tubing, perform a clean out, and then put your BHA back in place and get the well back on production.
Good deal. Thanks for that, Jeremy. So where do you guys see Access ESB heading in the future? You got bigger application envelope or next gen technology coming out?
Yeah, so on this one, I mean, the way we see it, we have I would say a two-pronged approach to that question. The first one, I will say we're at a stage where we see the early adoption stage on the a typical adoption curve, and now with Baker Hughes, we're trying to move on to the early majority stage. So as more operators start to use the system, word gets around. So we're making a huge effort, to make sure that every installation, is successful, and we can carry up that momentum. And the next one, it will be to expand further the capabilities of the system. Every step change in this approach has been led by operators, and I'll suspect the next one is going to be the same. Hey, we're happy to see challenges, and we would like for operators to bring their challenges to the table, work on a solution together, and I don't know, maybe we can move on to the ultra deep water territory, or expand the capabilities of the system based on the input of our clients.
Excellent. Thanks for that presentation, guys. We'll now transition to the question and answer portion of our webcast. I want to encourage everyone in the audience to get their question typed in so Jeremy and Rogelio can get you the questions you're looking for. Now let's get started with our first question. So there's always the question about a harsh environment of the high H2S. How is Access ESP adapting to that challenging environment?
So it depends. In terms of solids and that type of accumulation, the system is built from the ground up to go into those type of wells, a large amount of sand, debris, whatnot. Now, in terms of a harsh environment, when it comes to high H2S, high amounts of CO2, we go into two particular scenarios. One is by simple, material selection and metallurgy. All of the components on the wet mate system, no matter which well, they're all made out of Inconel alloys, the high nickel premium alloys. Same thing goes for any elastomers in the system. We use premium materials from the get-go. Now, when it comes to the big components, if there's high H2S, we have metallurgy for that. If we have high CO2, we have metallurgy for that. We actually do have what we call a high H2S system, which is built specifically for those kind of conditions.
Perfect. Thank you, Rogelio. So does the Access ESP system allow operators to inject chemical treatment downhole?
I can take that one. Yes, it does. And in fact, we do actively inject chemicals into wells that we have the Access ESP system in here in Alaska. So you can utilize either standard chemical injection mandrels or other methods of injecting fluids. And if you need to bullhead treatments, you can potentially do that as well. Like I said, you're able to retrieve the system if necessary, remove the portions of the retrievable assembly that are blocking your tubing. You could pump your full bore bullhead treatment and then reinstall the system as necessary.
Thanks, Jeremy. So how does the Access ESP system handle the high gas oil ratio?
I can talk about that one a bit as well. So we have the option of running gas vent subs, either just a ported sub or potentially a sliding sleeve with open slots or chokes to give you a wide range of options in handling gas. So that way you're able to essentially vent the gas from the system out to the annulus and not have to try to then force it through your pumps and cause you production issues with your pump and whatnot.
Excellent. Thanks, Jeremy. So how manageable is the ESP Access system for sand production tolerance? Have you run any type of erosion test or certification? In case of sort of shut-in scenarios, what are the main features of the ESP Access system to restart in high solids content?
So for that particular one, we don't have a specific protocol that we tested. However, the development from the ground was in Alaska with high production of sand to the point that we had up to almost a mile of sanding on top of one of the systems. So, of course, a clean out is needed to at first disposition of some of those solids so we can get to the first assembly. But really, truly, the fact that we have the first assembly being the first assembly that you pull out weighs about 40 to 50 pounds. It measures about 2 feet in length. So you can use all of the, let's say, the strength of the jars and your E-line or slick line to pull that first completion, that first element. Once that element is out, the second one, which contains the tubing pack off, it has a sealing element that is reseated, but that sealing element, also helps you to clean out the bore as you're pulling that subassembly out. That subassembly, same way, weighs about 100 pounds, is about 3 feet long, so very, very easy to get out of the hole with that amount of sand and accumulation. And therefore, by the time that you get to your two heavy runs, which is the pumps and the motor, your wellbore is fairly clean at that stage, and then you can pull out those components fairly easily. And like I said, we haven't had an issue pulling in wells with high debris and then reinstalling back on. Now, as far as the operational side of the question, I'm quite honestly, I'm not too familiar with the application on that side. So I mean, either Jeremy, I don't know if you know any details as to how the startup is any different from a standard startup, but otherwise we can take that question and provide either a Q&A document once we talk to our in-house experts on that side.
Yeah, generally in wells that we've been operating in that had high solids production, once we get the retrievable assembly out, depending on the particular situation, oftentimes they will run a clean out run with coil tubing, just to make sure you've flushed and cleaned out the wet made area and whatnot, and don't have any debris on the backside that might be causing you problems or causing you an inability to plug back in. But there is, a large amount of area there also where with some fairly wide tolerances that allow you some flexibility that if there is some debris there, you are still able to get the system plugged back in and start it back up as you normally would.
Great. Thanks, Jeremy. So what is the range in terms of power or horsepower for the system?
So we have two main sizes of the system. We call them the 375, 450. I mean, that goes by the diameter of the motor itself. So on the 375 series system, we cover the range of 130 horsepower for the motor load up to 400 horsepower. And it can be run on as small as 4.5-inch production tubing. Now for the 450 series, slightly larger in diameter, we cover the gap from 400 horsepower all the way up to 1,200 horsepower. So that's basically that encompasses the whole range of the system in terms of power delivery.
Thanks, Aurelio. So if you've got 5.5-inch production casing, that means high well potential is needed, correct? So what is the range in flow rate?
So in flow rate, we haven't run into an application above 20,000 barrels per day. And of course, it depends on how about the depth, the viscosity. So there are many parameters that go tied with that question. But talking in general terms, 20,000 barrels per day is very, very achievable in most conditions.
Thanks, Rogelio. So do you have a net present value calculation estimate of a 358 days of production that did not have to be deferred? I assume that's back to one of your case studies.
So we work with operators because they have variable the cost of interventions. They vary widely depending on where they're at. We take into consideration also deferred production. That's a big part of the equation. So we, as far as a general number, is very hard to just give one number. But with a particular situation, we can run a calculation very, very quickly for whoever is interested in that, inputting some of the numbers that they will have available. Standard intervention cost with the brig rate or versus the slick line rate, and make a cost assessment based on that. But I mean, just think about your cost of replacing a rig with a slick line in your particular location, and that's where we're at in terms of cost savings. I mean, it's very significant. I mean, 90% cost savings is very common.
Perfect. Thanks for that answer, Rogelio. So what about the ratings of the systems on the electrical and mechanical side? Can you give us some input on that?
Yeah, so as far as on the electrical side is very easy. Basically, our systems are 5,000 volts rated. So anything at 5 kV or less than 5 kV, we can cover that electrically. Mechanically, it sometimes depends on whether it's an open system. We call that an ACP because it's open to the annular. In that case, since all of our electrical connections are pressure balanced, we don't really have a rating. I mean, you can put it on a 20,000 PSI well and it should work. Now, typical operations for shrouded systems or systems that are in a can, we run around 10,000 PSI That's very, very common. And for our deep water system, that one is rated to 14,000 psi.
Perfect, Rogelio. So why is the retrievable system run in 4 parts? Wouldn't it be more efficient to put it in a single trip?
So yeah, as we touched upon the subject earlier, the main reason is retrievability. So keep the runs short enough so that they can fit on any standard lubricator, which therefore gives you the ability to run in live wells. So that's the main thing: keeping every run short, concise, so that you can displace debris on top of the system and you can run in lubricators.
Good deal. In concluding, do you, Rogelio or Helio, Jeremy, you guys have any concluding statements before we wrap up?
I mean, for me, just thank you for the opportunity. Thanks, Craig, World Oil, and thank you for everybody that attended for joining in. I mean, we really appreciate this, and if there's any questions, feel free to. I'm sure there's going to be a link or contact information for Jeremy, for myself, the Baker Hughes organization. So feel free to contact us with any questions that the audience may have.
Yeah, I'd like to echo Rogelio's sentiments there as well. I do appreciate everyone's time today. And, this really is a system and a technology that can provide significant advantages. It's something that I'm, very excited about and keen. I chose to move to a different segment in the industry after spending nearly, basically 20 years focusing on one thing and doing something else because I was excited by this technology in particular. So I think it's definitely something that is worthwhile taking a look at and seeing if it fits the applications that you might have.
Perfect. Well, we'd like to thank everyone for attending today's webcast. We'd also like to thank Baker Hughes for putting together this timely and informative presentation. Finally, an on-demand version of the webcast will be made available in the coming days and will be emailed to everyone. This concludes our presentation.